Hi, I'm Patrick Reagan. Welcome to the Advanced Networking Concepts Part 2, Server Virtualization. During this video, we'll discuss server virtualization, which is used to run virtual machines or virtual servers on a physical server. While this may seem to be a server topic, you'll find many network appliances can also run as virtual machines, including routers, switches, firewalls, and IDS/IDP devices, and as network administrators or architects, you will have to accommodate a virtual environment running on a network. You could also create a virtual network for learning and simulation using Graphical Network Simulator 3 or GNS3. As always, stick around for the practice question at the end to test your knowledge and help you prepare for the Network Plus exam. If you find this video helpful, don't forget to click the like button. And if you have not already, subscribe to the Pat Has Your Back channel for more tech training content and technical know-how. Virtualization is a technology that creates a virtual software-based version of the physical IT resource, such as a server, storage device, or network. This allows for multiple virtual instances to run on a single physical machine, each acting as an independent system with its own operating system and application. Types of virtualization include server virtualization, which divides a single physical server into multiple virtual servers; storage virtualization, which pulls storage from multiple physical devices into a single virtual storage unit; network virtualization, which recreates a physical network and software, allowing for the creation of virtual switches, routers, and other network components; and desktop virtualization, which separates a user's desktop environment from the physical device, allowing it to be accessed from multiple machines. This video will focus on server virtualization and desktop virtualization, while future videos discuss network virtualization. Early data centers could consist of hundreds of physical servers, with each server being assigned a workload, such as a specific application or service. Each server will have their own processors, memory, and storage. You want to select the right processor, memory, and storage that will efficiently run your service and application while keeping costs down. You don't want to buy extra processing, memory, and storage if you don't need it. However, most systems are mostly idle waiting for work to perform. As a result, most of the resources on an individual server were often wasted. In addition, all of the physical servers consume a significant amount of power. Eventually, data centers started to consolidate many physical servers to a single server running multiple virtual machines or virtual servers using Hyper-V or VMware EXI. Virtualization allows multiple operating systems, including different Windows operating systems and different Linux distributions, to be installed on the same physical computer without affecting or knowing about each other, and allows the sharing of hardware, including processors, memory, storage, network adapters, and USB ports. The large single server, with lots of processing, memory, storage, and network capacity, would run multiple virtual machines. Each virtual machine runs its own operating system and has its independent virtual CPU, memory, network, and storage. The physical server would split up the virtual workload amongst the physical server's processor, memory, and storage, so it looks like all physical machines are running at the same time. As a result, there was a significant increase in resource utilization while reducing overall costs and power consumption and reducing the number of physical servers. Virtualization allows you to run legacy software and operating systems and allows for cross-platform virtualization. Virtualization allows you to create a production, sandbox, test, and development environments. Since VMs can be isolated from other virtual machines can be used as a technology safe space or sandbox. Sandbox allows you to try updates and new or updated code without worrying about harming the production environment. Rollback features with snapshots and checkpoints allows you to test the updates and new or updated code. For test and development environments, virtualization can also be used to create a separate virtual environment for testing and development. Multiple VMs can be used to create a test environment, while other VMs can be used to create a development environment, which allows you to develop and write code, while keeping these environments separate from each other in the production environment. The hypervisor is a software component that is the virtual machine manager. It manages the virtual platform and guest operating systems. It manages the hardware, including processor, memory, networking, and security, and most require a CPU that supports virtualization. There are two types of hypervisors. Type 1 hypervisor is known as the native hypervisor because the hypervisor runs on top of the hardware. Type 1 hypervisors include VMware EXI and Microsoft's Hyper-V. A Type 2 hypervisor is also known as a hosted hypervisor, which runs on top of the host operating system. Type 2 hypervisors include Windows 10 and 11, VMware Player, Oracle VirtualBox, and Windows Virtual PC. Virtual technology allows you to run multiple virtual machines on the same physical computer. It allows you to run different operating systems and isolated operating systems on the same physical computer. It is assigned its own memory space. Hardware virtualization, which is part of the processor, is faster and easier to manage than software virtualization. Hardware virtualization, which is part of the processor, is faster and easier to manage than software virtualization, is included as Intel Virtualization Technology, or VT, and AMD Virtualization, or AMDV. Most virtualization softwares include VMware EXI, and Microsoft Hyper-V requires hardware virtualization to be enabled in the BIOS setup program for the processor. You'll need memory to run the OS operating system and memory to run each virtual machine. Each virtual machine will have its own disk space and operating system image. Each virtual machine will have its own virtual network adapters that will connect to the virtual switch. While you can allocate more memory and processing than you actually have, the system performance may be degraded. If a particular virtual machine is consuming too much processing or memory, you'll need to run the virtual machine on a physical host with more processing or memory. You will need to limit the amount of processing and memory that the machine is using, or you'll need to lower the priority of the virtual machine. Most client-side virtual machine managers have their own virtual internal network. Each virtual machine can connect to a network using virtual switches. Shared network addresses has the virtual machine share the same IP address as the physical host. The VM uses a private IP address internally and uses network address translation, or NAT, to convert the physical host IP. Bridge network address has the virtual machine connected to the physical network and is assigned its own IP address. Private address is where the VM does not communicate outside the virtual network. Networks can be further divided into external and internal networks where they can connect to the internet or not. Besides performing normal operating system backups, you can perform snapshots or checkpoints. A snapshot or checkpoint is a copy or backup of the VM at a particular point in time, which can revert to the VM to that point in time. Snapshot or checkpoint takes up disk space as it records every action or data change that occurs on the virtual machine. When a snapshot or checkpoint is created, it keeps track of all changes to the virtual machine. Snapshots and checkpoints are typically used when you want to make changes or upgrade a system and you want to restore a point to revert if the changes or upgrade does not go well. Remember that you need to delete the snapshot or checkpoints when the changes or updates have been deemed successful. The most dangerous type of threat when virtualization is VM escape. Virtual machines should be isolated from the host system and other virtual machines. Virtual machine escape is the process of a program breaking out of the virtual machine on which it is running and interacting with the hypervisor or host operating system, potentially gaining control over the entire host system, and can compromise other VMs running on the same physical hardware. To protect against VM escape, you need to keep the host operating system and hypervisor updated. Implement strict access controls and network segmentation to limit the attack surface. You should also use monitoring and logging to help detect VM escaping attempts and other security incidents and other rogue virtual machines. You should also use a compatible antivirus malware solution. A virtualization resource reuse vulnerability is a security issue that arises in virtual environments due to the improper handling or isolation of resources, leading to a potential security risk. For example, if there's a bug where hypervisors allocated shared memory areas between virtual machines, it can potentially enable data transfers and security vulnerabilities. This can lead to memory disclosure, information leakage, resource exhaustion, VM escape, side channel attacks, and snapshot disclosure. These vulnerabilities can affect the confidentiality, integrity, and availability of data and services in a virtualized environment. To prevent and fix resource reuse vulnerabilities, make sure you're using a secure hypervisor configuration. Keep the hypervisors up to date with the newest security patches. Regularly audit and monitor resource usage to detect abnormal behavior or resource exhaustion attacks. And lastly, educate administrators and users about the risks associated with resource reuse vulnerabilities. VM sprawl is when the number of virtual machines on a network reaches a point where administrators can no longer manage them effectively. In virtualization, you can create a VM quick and easily. Too many virtual machines can cause performance problems, affect backup procedures, use more resources that cost more money, and may not be updated on a regular basis. Also, unauthorized VMs can be used to implement rogue virtual machines. To prevent VM sprawl, you need to have a governance policy that includes a VM tracking and authorization system to create VMs and to manage their lifecycle. You should also perform a periodically audit to identify VMs that are not being properly managed by a VM lifecycle process and to have asset documentation listing all managed VMs. A physical to virtual migration involves converting the existing physical machine into a virtual machine that runs on the virtualization platform. This migration allows the VM to be hosted on a different hardware resource, providing increased flexibility, scalability, and resilience. Organizations may want to convert their physical servers into virtual machines because retiring aging hardware, reducing data center footprint, supporting legacy software, simplifying IT infrastructure management, supporting a test and development environment, and migrating to the cloud. Desktop virtualization is a method of stimulating a user's workstation so it can be accessed from a remotely connected device. Desktop virtualization is also known as thin client networking because the processing is centralized. Only mouse and keyboard inputs are sent across the network to the VDI servers, and video output is received by the client from the VDI servers. Virtual Desktop Infrastructure, or VDI, is a technology that is referred to the use of virtual machines to provide and manage virtual desktops. VDI can be hosted on on-premise virtualization servers or in the cloud. VDI can be persistent, which at the end of the session, the user potential settings are saved, or non-persistent, where at the end of the session, the user and personal settings revert to its original state. Desktop as a Service, or DAS, allows you to use a minimum client with a mouse, keyboard, and monitor with network connectivity to connect to a remote virtual machine that can have a large amount of resources. Question: which term allows multiple operating systems to work simultaneously on the same hardware? Answer: virtualization. Question: in virtualization, what is the software program that manages multiple operating systems on a single computer? Answer: hypervisor. Question: which of the following is an advantage of the virtual machine hosted on a physical server? Choose the best answer. Answer: reduces the amount of physical hardware. Question: which of the following is the primary security concern with the use of virtual machines? Answer: compromise the hypervisor. Question: which of the following can be used to provide access for an external vendor to the corporate network? Answer: VDI. Question: when using a DAS, which type of VDI saves the data and settings for the user? Answer: persistent VDI. Question: which of the following is an example of an on-premise VDI solution? Answer: desktop as a service, or DAS. Question: a security analyst wants to preserve the present state of the virtual server, including the memory content. Which of the following backups should you use? Answer: snapshot. Question: which of the following describes the ability of code to target a hypervisor from inside a guest OS? Answer: VM escape. Question: you have a PC that's critical to business operations and a costly hardware failure is imminent. What options can you offer without incurring large costs? Answer: perform a physical to virtual migration. For more information, visit these sites. In summary, virtualization allows multiple operating systems, including different Windows operating systems and different Linux distributions, to be installed on the same physical computer without affecting or knowing about each other, and allows the sharing of hardware, including processors, memory, storage, network adapters, and USB ports. Virtualization allows for a significant increase in resource utilization while reducing overall costs and power consumption and reducing the number of physical servers. Virtualization allows you to run legacy software and operating systems and allows for cross-platform virtualization. Virtualization allows you to create a production, sandbox, test, and development environments. The hypervisor is a software component that is the virtual machine manager that manages the virtual platform and guest operating systems and manages the hardware, including processor, memory, networking, and security. The most dangerous type of threat when virtualization is VM escape, whereas virtual machine escape is the process of a program breaking out of the virtual machine on which it is running and interacting with the host operating system. Desktop virtualization is the method of simulating a user workstation so it can be accessed from a remotely connected device. Virtual desktop infrastructure, or VDI, is a technology that refers to the use of virtual machines to provide and manage virtual desktops. Thank you for watching this video. The next video will be Advanced Networking, Part 3, Cloud Concepts. If you like this video, click the like button, and if you have not already, subscribe to the Pat Has Your Back channel. Thank you.